Welcome to a brief lecture on gears. In this lecture, we will discuss two numerical problems on gears from the previous university examinations of KTU. Question number 1. Two 20-degree involutes per gears mesh externally and give a velocity ratio of 3. The module is 3 mm and the addendum is equal to 1.1 module. If the pinion rotates at 120 rpm, determine the minimum number of teeth on each wheel to avoid interference, and the second part to find the contact ratio. The given data: the spur gears having involute profile for the teeth, pressure angle phi that is equal to 20 degrees, velocity ratio that is essentially the gear ratio which we can denote it by capital G is equal to 3. Module M is equal to 3 millimeters. Addendum can be denoted by small a, that is equal to 1.1 module. Remember, 1.1 into 3 millimeters. So in millimeters, the addendum will be equal to 3.3. The addendum ratio, that is 1.1. Number of teeth on the pinion, let it be capital T suffix P. Number of teeth on the gear, let it be TG, and gear ratio G is equal to number of teeth on the gear divided by number of teeth on the pinion. Usually the smaller gear is considered as the pinion and the bigger one is the gear wheel. So gear ratio G is TG by TP, that is equal to 3. Pitch circle radius of the gear, let it be equal to capital R, and pitch circle radius of the pinion, let it be small r. Now we have an equation for minimum number of teeth required on the gear wheel to avoid interference. Interference is something what we need to prevent. So minimum number of teeth on the gear wheel, that is the bigger gear out of the two mating gears, to avoid interference is given by Tg is equal to 2 times AW, A suffix W, divided by square root of 1 plus 1 by G into 1 by G plus 2 into sine square phi minus 1. Remember, this minus 1 is outside the radical, and where G is the gear ratio and phi is the pressure angle, and A suffix W, that is the addendum ratio. It is not the addendum in millimeters. So here, for example, the addendum is given as 1.1 module. So this AW here will be 1.1. It is not equal to 3.3 m. That is the addendum in millimeters. And especially here in this expression for TG, this is actually a number and denominator is already dimensionless. So the numerator also must be unitless or dimensionless. And we know that gear ratio is equal to Tg by Tp, and which is equal to capital R by small r, that is pitch ratio of pitch circle radii of the gear and the pinion. The bigger one is the gear, that is capital R, and small r is the pitch circle radius of the pinion, and which is equal to Np by Ng, that is RPM of the pinion by RPM of the gear, and that is also equal to the angular velocity of the pinion by angular velocity of the gear. So this ratios you must remember. Gear ratio G is equal to Tg by Tp, which is equal to R by capital R by small r, that is equal to Np by Ng, that is equal to omega P by omega G. So to avoid interference, Tg is given by this relation. So we can substitute AW, gear ratio G, and the pressure angle in this relation. So what do we get? Tg is equal to 2 into 1.1 divided by square root of 1 plus 1 by G. G is equal to 3. 1 by 3 into 1 by 3 plus 2 into sine square 20, which is sine 20 whole square, then minus 1. Remember, minus 1 is outside the radical. So once you do this, you will get Tg is equal to 49.25. We know that it is a number, so we will round it off to the next whole number. But again, one concern here, the gear ratio is given as 3. So number of teeth on the gear, if it is Tg, number of teeth on the pinion will be Tg divided by the gear ratio. So of course Tg divided by 3. So therefore it must be a multiple of 3. So if Tg is equal to 49.25 and if you round it off to the next multiple of 3, then you will get 51. 51 is the multiple of 3 after 49.25. So Tp is equal to Tg by 3, then it is 51 by 3, so that is 17. So number of teeth on the gear to avoid interference is 51 and number of teeth on the pinion to avoid interference is 17. So the first part of the question is over. Now we will try to find out the contact ratio, that is the second part of the question. So the contact ratio is given by arc of contact by circular pitch, and whereas the arc of contact is equal to path of contact divided by cos phi, where phi is the pressure angle. And then again path of contact is equal to path of approach plus path of recess. Path of contact means the path along which the teeth of mating gears slide from the beginning of tooth engagement to the end of tooth engagement. And of course the pitch point P is in between. So from the beginning of tooth engagement up to the pitch point is known as path of approach. So path along which the gear teeth slide from the pitch point to the remaining part, that is up to the point of tooth disengagement, that is called path of recess. And path of approach plus path of recess is equal to path of contact. It's a straight line distance. And path of approach, it is given by the equation square root of Ra square minus R square cos square phi minus R sin phi. And where capital R suffix A, that is the addendum circle radius of the gear, and capital R is the pitch circle radius of the gear. Path of recess is given by square root of small Ra square minus R square cos square phi minus R sin phi, where small r suffix A is the addendum circle radius of the pinion, and addendum circle radius of the gear capital R suffix A is found by adding addendum to the pitch circle radius of the gear wheel, that is capital R plus A, that is equal to capital R suffix A. So small r plus A, that is equal to small r suffix A, that is addendum circle radius of the pinion. And we know that A is equal to 1.1 module, that is 1.1 into 3 mm. So A is equal to 3.3 mm. So we have the expressions for path of approach and path of recess, and if you add the two, you will get path of contact. And now we have module M given by pitch circle diameter by number of teeth on the gear. That's a basic equation. For the gear, module M will be equal to 2 times capital R by Tg, and for the pinion, module M is equal to 2 times small r divided by Tp. Therefore, equating M is equal to 2 times capital R by Tg, so we will get capital R is equal to M into Tg by 2, and small r is equal to M into Tp by 2 from the ratio 2r by Tp is equal to M. Now we will find out the pitch circle radius of the gear and the pinion. Pitch circle radius of the gear capital R is equal to M into Tg by 2, and we know that module is 3 mm, so 3 into 51 divided by 2, so we will get 76.5 mm. Number of teeth on the gear we already found out, 51, and small r is equal to M Tp by 2, M is 3 mm, into number of teeth on the pinion is 17 divided by 2, 3 into 17 by 2, so we will get 25.5. And now the addendum circle radius of the gear wheel is equal to capital R plus A, that is 76.5 plus 3.3, both are in millimeters. So addendum circle radius of the gear is equal to 79.8 mm. And the pressure angle phi, we know that it is 20 degree for the given problem. And addendum circle radius of the pinion, that is equal to small r plus a. Small r, that is pitch circle radius of the pinion, is 25.5 and addendum is 3.3 mm. So we will get Ra is equal to 28.8 millimeters. All these dimensions are now in millimeters. Path of contact, so that is given by this relation, and if you add both path of approach and path of recess, then you will get this equation. So path of contact is equal to square root of capital Ra square minus capital R square cos square phi plus root of small r suffix a square minus r square cos square phi, then minus r plus r into sin phi. So you substitute capital R suffix a, capital R, small r suffix a, small r, and the pressure angle. So if you substitute and do the calculations, you will get path of contact is equal to 15.737 millimeters. And we know that the arc of contact, that is the arc distance that is measured along the pitch circles corresponding to the path of contact. Path of contact is a straight line distance. Arc of contact is equal to path of contact divided by cos phi, which is equal to 15.737 divided by cos 20. So you will get 16.747 millimeters. And now we will find out the first item to be found out, that is the contact ratio. In fact, that is the second item to be found out, that is contact ratio. Contact ratio is arc of contact divided by circular pitch. Arc of contact is 16.747 millimeters divided by circular pitch. Now circular pitch is denoted by P suffix C, that is equal to pi into module, that is pi into d by t. So pi into module, here module is 3 millimeters, therefore circular pitch PC, that is equal to 9.425 mm. So once you substitute arc of contact in millimeters, that is 16.747, and circular pitch in millimeters 9.425 mm, so you will get contact ratio, that is 1.777. So approximately 1.78. So that is the answer to the second part of the question. Now the second question. Two 20-degree gears have a module pitch of 5 millimeters. The number of teeth on the pinion is 20 and the gear ratio is 2. If the pitch line speed is 1.2 meter per second, assuming addendum is standard and is equal to 1 module, find 1 angle turned through by the pinion when one pair of teeth is in mesh, and 2 the maximum velocity of sliding. So we have 2 items to be found out. Now the given data, assume involute profile for the teeth. Module is given as 5 millimeters. Standard addendum is to be assumed. A is equal to 1 module, that is in millimeters it will be equal to 5 mm. Gear ratio is given as 2 and number of teeth on the pinion, that is given as 20. Gear ratio is Tg by Tp. Tg by Tp is equal to 2. Therefore, Tg is equal to 2 times Tp. So since Tp is given as 20, Tg will be 2 times Tp, that is 2 into 20, that is 40. So number of teeth on the gear is 40. And also we have the ratio G is equal to Tg by Tp, which is also equal to capital R by small r, pitch circle radii of gear and the pinion, that is equal to Np by Ng, that is RPM ratios of the pinion and the gear. Then that is equal to omega p by omega g, that is the ratio of angular velocities of pinion and the gear. See, the pitch line velocity v, that is actually the tangential velocity of the 2 mating gears at the pitch point. So the tangential velocity, that is angular velocity into radius or rotation. So pitch line velocity for both gear and the pinion will be the same. So V is equal to omega p into r, where omega p is the angular velocity of the pinion and small r is the pitch circle radius of the pinion, and that is also equal to omega g into capital R. Omega g is the angular velocity of the gear multiplied by pitch circle radius of the gear. So omega p into small r, which is equal to omega g into capital R, that is equal to 1.2 meter per second, that is given. So here for the pinion small r, we know that is equal to m into Tp by 2. So that is module here is 5 mm, 5 into number of teeth on the pinion is 20, 5 into 20 by 2, so that is 50 mm. In meters it is 0.05 meter. For the gear, capital R is equal to m into Tg by 2, module is again 5 mm, into Tg is number of teeth on the gear is 40, 5 into 40 by 2, that is 100 millimeters, and that is equal to 0.1 meter. Now you substitute in this relation for pitch line velocity, omega p into small r is equal to 1.2, and omega p is equal to 1.2 divided by small r. Remember, pitch line velocity is in meter per second. Therefore, when you substitute over here, the radius also must be in meters. So omega p is equal to 1.2 meter per second divided by 0.05 meter. So you will get 24 radian per second. That is the angular velocity of the pinion. Similarly, angular velocity of gear into the pitch circle radius of the gear, that product also gives the pitch line velocity 1.2 meter per second. So omega g is equal to 1.2 divided by capital R, that is 0.1 meter. So we will get 12 radian per second. So we got the angular velocities of both the pinion and the gear. How to get the angle turned through by the pinion when one pair of teeth is in mesh? Angle turned through by the pinion is equal to arc of contact divided by circumference of the pinion measured along the pitch circle multiplied by 360. So angle turned through by the pinion when one pair of teeth is in mesh, that is equal to arc of contact divided by 2 pi times small r into 360. Similarly, if you want to find out angle turned through by the gear wheel when one pair of teeth is in mesh, that will be then equal to arc of contact divided by 2 pi capital R into 360. See here the arc of contact that you have to substitute over here. Arc of contact we already know, that is equal to path of contact divided by cos phi. Path of contact is equal to path of approach plus path of recess. Here we have to find out path of approach and path of recess separately, because we have to find out velocity of sliding. So we will find out path of approach and path of recess separately. So path of approach is equal to square root of capital R square minus capital R square cos square phi minus R sin phi, let it be equal to x, and path of recess square root of R small r suffix a square minus R square cos square phi minus small r sin phi. See, we already found out pitch circle radius of the gear, that is 100 mm, and pitch circle radius of the pinion small r is equal to 50 mm. So the addendum circle radius of the gear, that is equal to capital R plus a. So 100 plus addendum is 5 mm, so we will get 105 mm. Addendum circle radius of the pinion is equal to pitch circle radius of the pinion plus a, that is addendum, that is 50 plus 5, so 55 mm. Pressure angle is 20 degree. See, on substitution here, you will be able to calculate path of approach and path of recess. So path of approach x is equal to, so on substitution you get 12.65 millimeters. Path of contact then will be the sum of path of approach and path of recess. So that is x plus y over here, that is 12.65 plus 11.49. So we will get 24.14 millimeters. Now the arc of contact Arc of contact is given by path of contact divided by cos phi. So that is 24.14 millimeter divided by cos 20. That is 25.69 millimeters. Then circumference of the pitch circle of the pinion, that is 2 pi small r. That is 2 pi into pitch circle radius of the pinion is 50 mm. That is 314.16 millimeters. That is circumference of the pitch circle of the pinion. When one pair of teeth is in mesh, the angle turned through by the pinion is equal to arc of contact by this circumference into 360. That is 25.69. That is arc of contact in millimeters divided by the circumference of the pitch circle radius of the pinion in millimeters is 314.16 into 360. So we will get 29.44 degrees. This is the angle turned through by the pinion when one pair of teeth is in mesh. That is the answer to the first part of the question. Now the second part of the question, that is the maximum velocity of sliding. See, the maximum velocity of sliding, let us denote it by Vs max. See, that is actually maximum of the two possible velocities, two sliding velocities. One is velocity of sliding at the beginning of tooth engagement, that let us denote it by Vs start, or the velocity of sliding at the end of the tooth disengagement. So you can write Vs end. That is, the maximum sliding velocity possibly may occur at the beginning of tooth engagement or at the end of tooth engagement. So here it's a mistake, at the end of tooth engagement or at the time of tooth disengagement. Velocity of sliding at the time of starting tooth engagement, let us denote by Vs start, that is equal to angular velocity of the pinion plus angular velocity of the gear, that is omega p plus omega g into path of approach. So let us denote it by x, and we already obtained the path of approach as 12.65 mm. In meters it is 0.01265. So omega p plus omega g into path of approach, that is the velocity of sliding at the beginning of tooth engagement. That is 24 plus 12 into 0.01265. Make sure that you substitute in meters if you want to get the velocity of sliding in meter per second. So 24 plus 12, 36 into 0.01265, you will get 0.455 meter per second. This is the velocity of sliding at the beginning of tooth engagement, that is Vs suffix start. Then Vs end, that is at the time of tooth disengagement, velocity of sliding at the time of tooth disengagement or at the end of tooth engagement. So in that case it is omega p plus omega g into path of recess, and path of recess we have already calculated. Here we have denoted it by y, that is equal 11.49 mm, that is 0.01149 meters. So omega p plus omega g, 24 plus 12 again, multiplied by 0.01149, remember that is in meters, and then velocity definitely will be in meter per second. So velocity of sliding at the end of tooth engagement, that will be equal to 0.414, or at the time of tooth disengagement, 0.414 meter per second. See, out of the two velocity of sliding, two possible cases, and this velocity, that is 0.455 meter per second, happens to be the maximum. So therefore velocity of sliding maximum here is 0.455 meter per second. That occurs at the beginning of tooth engagement. That completes the solution. Thank you.